Okay, welcome to another section of the projectile motion. Now, in this section, this is the horizontal projection. If you missed our last video, you can click on the link below concerning vertical projection. And this is peculiar to horizontal projection. Please don't forget to subscribe. Click on the notification button below for more notifications of our videos. You can share and like. Now, in today's video, we are going to treat this very well, just like we did in our previous video under vertical projection. The diagram here we have is when you have, unlike vertical projection, in vertical projection you are projecting like this, upward. But in horizontal projection, you are projecting this way. That's the difference. Vertical projection, you are projecting vertically upwards, no displacement at all, like this. But in horizontal projection, it's more like throwing something. If someone asks you, throw something to me. Once you are giving the person you are trying to throw, what you are doing is called horizontal projection. So that is with the diagram we have here. This is just a schematic diagram of it. So throwing something to someone and it's falling like this to the ground. You throw, it's falling like this to the ground. There is something you need to know, or there are things you need to know about this. First, from our diagram, we can see that under horizontal projection, we have two components. The velocity has two components. You can resolve the velocity into horizontal component or the vertical component. At any point, this velocity can be resolved because there is a displacement. As you can see, it has a range. Unlike the vertical projection, there is a displacement. So it has a range from the point of projection, which is this point, to the point of landing. The horizontal, which is R. So we are coming to this. Now, what do you do here? You have to consider these components. We don't just solve straight. You have to consider these components. Although, most times, they don't normally ask questions on, much questions don't come out on horizontal projection. But for knowledge's sake, please pay very much attention on this. Now, let's see how this thing works. We have Vx, horizontal component, Vy here. When it is about to hit the ground, we also have Vx max. Max is telling us that it's about hitting the ground. We have Vy max, and of course, if you missed our video in vectors, you can go and get our vector. Now, this is the resultant, Vmax. So we are going to get this in each case. This one is called the vertical component. Vy is called the vertical component of the velocity at any instant in time. Now, something you need to know as we are going to move further is this. The horizontal component is constant. You are going to understand what I mean by that. It's constant, it doesn't change. And it has no acceleration due to gravity. So anytime you are talking about the horizontal component, always remember, acceleration due to gravity does not act horizontally. It is zero. It can only act when something is going towards against gravity. When you throw something like this, at the initial stage it is moving this way before it starts falling down. At that point, it has no acceleration due to gravity. And acceleration due to gravity will start acting once that thing starts falling down or going up. So that's why I say in vertical component, it has no initial velocity. As you can see, that is u is zero, but it has acceleration due to gravity. So having this in mind, let's try and see our formulas. Okay, first, before we talk about the time of flight and the maximum height, we need to get this. We need to get what these velocities will give us before we enter into time of flight, maximum height, and the range. Now, what do you think Vx will give us? Vx, V sub x, is called the horizontal component. I'll abbreviate the horizontal component of the velocity at any time t, that is Vx. Any particular time. It can be any time on the motion, any time. But once it's about to hit the ground, it changes to max. But any time it can be here, it can be here, it can be here, it can any point here. That is what I mean by any time t. Some tests call it any instant in time t. It doesn't matter. So what do we do about that? We also make use of our equations of motion. We say that v is equal to u plus gt. V is equal to u plus gt. Now for this case time, in this case now, our v, we are interested in Vx. So this changes to Vx is equal to horizontal has initial u plus, it has no acceleration due to gravity, like we duly noted. So this is 0. This time this gives us 0. So Vx is equal to the initial velocity. Always note this. This is the reason why we say that V component of the velocity is always constant. So in case they ask you quickly in the hall, what is the horizontal component of the velocity at time, after 2 seconds? You don't need to stress your life. There's nothing to solve. Just know the initial velocity in that question. If they tell a body was projected with an initial velocity 20 meters per second horizontal, what is the horizontal component of the velocity after 5 seconds? You don't need to solve anything. Your answer is 20 meters per second. Because as you can see, the horizontal component of the velocity is constant. It is equal to the initial velocity of the projectile. So that is how you get this. Now let's see what the vertical component of the velocity would be. Now the vertical component of the velocity at any instant in time t, which we call v sub y, is simply, we can also make use of this u plus gt. Now our interest is in v sub y. Remember, vertical component has no u, initial velocity is 0, while it has gt. So 0 plus this, v sub y gives us gt. This is the first formula for the vertical component of the velocity at any instant t. If t is given, make use of this, or you can also use the third equation of motion. V square is equal to u square plus 2gh. 2gh. At this point now, our Vy squared, remember this is 0 plus 2gh. 0 plus this gives us that Vy squared is equal to 2gh. Therefore, Vy is square root of 2gh. So, but more often, this is used because the time t is normally given. Just multiply by acceleration due to gravity in bracket. But in case t is not given, they say calculate, they did not mention t, but they know the height at that particular point. That is what I mean. This h is not the maximum height. This h here is, for instance, I'm trying to calculate the vertical component of the velocity at this particular point. Remember, it has a height from here to the ground. From here to this point. That is small h. If I'm calculating here, it has a height. This is also called small h. So any other height that this particular object makes that is not the maximum height is small h. And that velocity, sometimes they can ask you to calculate the vertical component of the velocity at 2 meters. If the maximum height is 7 meters. So that means we're making use of this. That is also a velocity at any instant at 2 meters. Okay. Now, that is all we need to know about the velocity. The velocities at any instant in time. Now, how do we get v? Now, v is the resultant. So following vector, we know if we bring this out, all we have is this. Vx, Vy, then we have V. So if you complete this, here becomes also Vy. Vy. So by Pythagoras theorem, V squared is equal to Vx squared plus Vy squared. Therefore, V is simply square root of Vs squared plus Vy squared. So we already know what Vx is. Vx is equal to U, while Vy is equal to Gt, or square root of 2gh. You just get them separately, input them here, you get your answer. So this is the formula. Now the question now is, what is V called? V is called the velocity of the object at any instant in time t. At any instant in time t. That is V. Have you seen the difference? This is called the horizontal component. Here we have horizontal. Here, this is called the vertical component. Here there will be vertical. But when there is no vertical, there is no horizontal, it's just called the velocity at any instant in time. That means they want you to solve for V. You cannot solve V if you don't know Vx, as you can see, and if you don't know Vy, which we can quickly get with our formulas. Okay, that is that for any instant in time. So what happens to V when it's about to hit the ground? What happens to V when it's about to hit the ground? Let's see, just similar way. So what we have V max x when it's about to hit the ground. So Vx max, which is also constant, the horizontal component of the velocity before hitting the ground. Or you can call it before landing. That is called Vx max. Vx max, the horizontal component of the velocity before landing. Vx max. So using the equation of motion, anyone you like you use, we have that V is equal to U plus, now before landing, everything is maximum. The time it will take from here to landing is called the time of flight. The time from the point of projection here to the point of landing is called the time of flight. So we are not making use of ordinary time because we are talking about before landing. So this is not just G small t but capital T. That's the difference. Before landing. So in this case, we are talking about Vy max. Sorry, Vx max. Vx max. Now, Vx max, we know when we are talking about horizontally, we only have U. G, this is 0. G does not exist. So since G is 0, everything nullifies. So this is our formula. The horizontal component of the velocity before landing or before hitting the ground is equal to the initial velocity. This is why from the onset I said, note, it is constant, it does not change. Anything horizontal, velocity is equal to the initial velocity. Now what about the vertical component? Now the vertical component, we have the vertical component, which is Vy max. You can equally use any of the two formulas. You can decide the first equation of motion, this plus this. Remember, we are making use of the capital T now. So this becomes with Vy max is equal to, this is 0. Vertical component has no initial velocity, so this is 0. So Vy max is equal to Gt. As you can see, they are very, very similar. Very similar. The difference is in t. In this max, we are making use of the time of flight. But here, we are making use of ordinary time that is given to you in the question, not the time of flight. We are making use of small t. While here, we are making use of capital T. You can also say that v y max from third equation of motion is square root of what? 2g h. So everything about max is dealing with maximum. Time of flight, the total time, the total height, the highest height. So that's what we have now. Okay, now the next is, how do you get the velocity before hitting the ground itself, which is Vmax? The velocity before hitting the ground, Vmax. So the velocity before hitting the ground is still similar to the previous one. So the velocity before hitting the ground, which is Vmax itself, is, if you bring this out also, we have something of this nature, Vx max, Vy max. Now this is the velocity before hitting the ground, Vmax, which is the resultant velocity. So what do? If you still complete this to get your right angle triangle, here also becomes Vy max. So by Pythagoras, we have that Vmax squared, which is this, is equal to square root, Vx max squared plus Vy max squared. So that means that this is square root of Vx mass squared plus Vy mass squared. You get your velocity before hitting the ground. Another thing they can ask you is the direction of the velocity before hitting the ground, which is theta. The direction of the velocity before hitting the ground. So how do you solve this? We have opposite, adjacent. Opposite, the side facing the angle is the opposite. You have opposite, adjacent. So we are making use of tan. Therefore, tan, let's change this to phi. Tan phi is equal to opposite, which is Vy max, divided by the adjacent, which is Vx max. So anything you get, take the tan inverse, that is the direction of the maximum velocity, which is the velocity before hitting the ground. So this is the concept of velocities when it concerns horizontal projection. This you can never see in the textbook you read, so be very, very careful. Always like, share, so that others will gain from the knowledge you are gaining right now. So now let's move on to the terms also used, which is time of flight, maximum height, and range. Okay, now first let's treat the height, the maximum height. And the maximum height from our diagram is from this point to this point. Any other height is small height. From here to this point is capital H. So we can get our capital H using any of the formula we like, where H appears in the equation, first, second equation, and third equation. So H is equal to UT plus half GT squared. So the maximum height here, remember vertically this is 0, at maximum height this is 0. So H is simply half GT squared. As easy as that. So the time of flight, half GT squared. Be very careful here. In this case, we're making use of the time of flight, horizontal projection, because it's just coming down from a point. So yeah, this is T2 and it's still equal to the time of flight. Next thing we need to do is to get our time of flight. Time of flight can easily be gotten from this. It's direct. Make T the subject of the formula from this equation. T squared becomes 2h over g. If you make t the subject, the time of flight becomes square root of 2h over g. It's as easy as that. So the time of flight is this. That is what makes horizontal projection the easiest projectile to ask you in the hall. But other concept of the vertical of the velocities is normally asked during your WAEC, but note them in case they ask you that in the hall. Now, next thing we need to do is the range. As you can see, what is range? Range is the horizontal distance covered from point A to point B. Point A is the point of projection to the point of landing. The horizontal distance covered from here to this point is the range. So what is range? You can get it from the second equation of motion, that R is equal to ut plus half gt squared. That is R. But we know anything happen horizontally, acceleration due to gravity does not occur. So this is 0. So what we have is u plus everything here is 0. Due to this will cancel everything here. So R is equal to ut. This is the formula we can use. R is equal to u. We already know what t is. T from R is the time of flight, which is square root of 2h over g. So you can make use of the formula directly as the range. So the range is equal to square root of u times, u is equal to, R equal to u times what? Square root of 2h over g, which is R is equal to ut. So this is all you need to know about horizontal projection. Even at your higher level, this is the foundation. Now we are going to solve a question to see how to apply these particular formulas. The question we have here says, a ball is thrown horizontally from the top of a cliff 40 meters high with an initial velocity of 20 meters per second. Calculate the following. So we have question number 1. We should calculate the time of flight, that is question I, the total time taken to fall to the ground, that is the time of flight. II says the vertical component of the velocity after 1.4 seconds. The vertical component of the velocity after 1.4 seconds. III says the vertical component of the velocity before landing. The vertical component of the velocity before landing. Now we have IV. IV says the horizontal component of the velocity before landing. The horizontal component of the velocity before landing. Now V says the range, the horizontal range. That we should calculate the horizontal range. Now this is how to solve the question. Now question number 1. First of all, we have two things. We have h, which is 40 meters from the top of a cliff horizontally. First of all, they mention horizontally. So that is how we know that this is a horizontal projection. We know that. Now, next thing is, if I'm throwing something from the top of a cliff, that is the highest. They didn't say upward. I'm throwing like this down. So the highest height I have there is 40 meters. That is the height of the cliff. And I also have the initial velocity u, which is 20 meters per second. So I question says that we should calculate the total time taken to hit the ground. So the total time taken to hit the ground is t, time of flight. Sometimes they don't mention time of flight. The total time taken to hit the ground, that is t. So t, from our formula under horizontal projection, is equal to square root of 2h over g. So what we do is 2 times, what is h? 40, divided by, g is given in bracket as 10. So this gives us square root of 8, which is 2 root what? 2 seconds. 2 root 2 seconds. If you are told to leave your answer in short form. But if not in short form, you can take the square root of 2, then you multiply by 2 and get the other answer in decimals. Now, II question says, II says, the vertical component of the velocity after 1.4 seconds. Vertical components. So our mind should gear towards what? Vy. But is it Vy max or Vy? It's just Vy. Why? Because they didn't say before hitting the ground or before landing. So we are making use of Vy. And since we know our time of flight already, so we can simply use GT, Vy. We are making use of GT. So what is G? 10 times, what is the time after 1.4 seconds? This is the 1.4. 10 times this will give us 14 seconds. Sorry. 14 meters per second. So this is the velocity before, after 1.4 seconds. Now the next question now says, the velocity before landing. What is the vertical component of the velocity before landing? Have you seen the difference? The vertical component before landing. So we are talking of what? Vy max. And that is GT, capital T. So in this case, we have 10 times before landing. What is T? 2 root 2. When you multiply this, what we have is 20 root 2 meter per second. 20 root 2 meter per second. Before landing. We are talking about max. Now, question 3. IV says, what that we should calculate the horizontal component of the velocity before landing. The horizontal component of the velocity before landing. So what is the horizontal component? We are talking about x. Is it ordinary Vx or Vx max? It is Vx max because they said what? Before landing. And this is constant. We are told from the beginning of our video that this is equal to u. There's nothing to solve. Therefore, Vx max is simply 20 meters per second. 20 meters per second. Now the next thing we are asked to do here is to calculate the range, the horizontal distance covered. What is the range? V. The range R is equal to UT. UT. Our U is 20 times our T, which is what? 2 root 2. So our range is giving us 40 root 2 meters. It is the horizontal distance covered, 40 root 2 meters. If you have any question, drop it in the comment section below, or you can just scroll down a little bit and you see anything you need. Okay, thank you.